everyone, I'm Ms. Fazzone, and today we're going to be factoring the difference of two perfect squares. So I actually have an acronym that I use for the difference of two squares. I kind of dropped the word perfect, and I call it DOTS, the difference of two squares. Yes, the perfect should be in there, but I pulled it out. Alright, so what is factoring? My students get so mad at me because I put this on the board every single lesson when we're factoring because they forget what does it mean. So factoring is writing a polynomial as a product. We can also say it's reverse distributive property. These are my two definitions I usually use. So it's the opposite of multiplying out binomials, trinomials, monomials. Okay. Alright. So this is review from the last video. So I'd like you to pause the video and do these. If you haven't seen these yet, you should go back and watch my video on multiplying trinomials. So remember, when we're writing these out, we're looking for two binomials. Remember, x times x is x squared. That will multiply to negative 90 and add to 13. So our product is negative 90, and our sum is 13. And I'm going to tell you right now, I did this so long ago, I have no idea what the answer is. So let's go through, start with 1, work our way up. 1 times 90, 2 times 45, 3 times 30, 4 doesn't go in, 5 times 14, no, 5 times 18, oh, there it is, 6 times 15, 7 doesn't work, 8 doesn't work, and 9 times 10. Alright, so since we're multiplying to negative, we need one of our numbers to be negative. But remember, our sum is 13. We're going to add up to a positive. So that means our smaller number needs to be negative. So when we add across, negative 1 and 90 is 89. Negative 2 and 45 is 43. And let's find our 13. 13 is right here. Negative 5 plus 18, so that means our answer is x minus 5, x plus 18. Pause the video, try 2 on your own. So for number 2, put down here. This time we're multiplying to 96. Our product is 96 and our sum is negative 28. Let's see. It's not 1 times 98, 2 times 48, I'm going to start with 3. 3 times 32, not quite, 4 times 24, ooh, that's it. Because we're multiplying to a positive and adding to a negative, what has to be true about our signs? Since it's a positive, they need to be the same sign. Since we're summing to a negative, they both have to be negative. Okay? So that means we get x minus 4 and x minus 24. And that's factoring those two. Okay? So that's a review of yesterday's lesson on factoring from the chart. Okay, so now let's do a quick review on GCF. So that top one, what's the GCF? What can go into all 3 of those? Hopefully you recognize it's 5. So my GCF is 5, right? So reverse distributive property, instead of multiplying, it's the reverse, we divide. So we get x squared minus 2x plus 3, parentheses, and put our GCF on the inside. Now you could try to factor this, that's actually not factorable the inside. This trinomial is prime. Next one, we need our GCF. Little harder GCF. Anyone see it? I see it. It's 13. This is one I like to mess with kids. So my GCF is 13. 13 goes into 26 and 39. And then who has the smaller exponent? X squared. So let's divide. We get 2x minus 3 parentheses GCF on the outside. Right, so we just factored using GCF. So that was the first factoring lesson that I taught. Alright, so now we're going even further back. Let's multiply these out. So pause the video, double distribute, FOIL, however you learn how to do this. If you do not know how to do this, again, you should not be on this lesson, you should back up. Okay. Alright, so I'm going to multiply my x's. So x has to multiply by both of those. So x squared minus 7x. And then my 7 has to multiply by both of these. So plus 7x minus 49. Don't forget to multiply. I get a lot of kids that tell me that's 0. So what do you notice about these? Negative 7 plus 7 cancels to 0. So my answer is just x squared minus 49. Next one, same idea. We're going to multiply that 5x times everything in the parentheses. Right? 5x by everything. So that's 5 times 5 is 25x squared minus 45x. Then the same thing with our 9. Positive 9 times 5x is positive 45x. 9 times negative 9 is negative 81. Those middle two terms cancel out, and we're left with 25x squared minus 81. I hope at this point you have noticed a pattern. Last one, 2 times everything in the parentheses, 4x squared minus 26x. Then we have our positive 13 times everything, positive 26x minus 169. Middle two terms cancel, 4x squared minus 169. So, why in all of these did the middle terms cancel? What do you notice about the original problem? X plus 7, x minus 7. 5x plus 9, 5x minus 9. 2x plus 13, 2x minus 13. These are called conjugates. They're the same binomial, their only difference is their sign. One is positive, one is negative. Because that happens, the middle term ends up canceling out. We are left with perfect squares being subtracted. The difference, subtraction difference, of two perfect squares. The difference of two perfect squares, let's see, do I have it written? Oh, I do. Binomials written in the form ax squared minus b, where both terms are perfect squares, including the x's. So the x also has to be a perfect square. We could have x to the 4th, x to the 6th, as long as it's even. But if that was an x cubed, this wouldn't work. So both a and b have to be perfect squares, and it has to be subtraction. If it's not subtraction, this will not work. Because these two numbers have to be opposites for it to be negative. Otherwise, you're going to be, stuff ends up adding, so it doesn't work. Alright, so these are super simple. These, I always tell my students, put your pencils down, don't even write anything, because you will get lost. You really just have to pay attention and listen. So I recognize this as a difference of two squares. So I'm going to put my two sets of parentheses. What times itself is x squared? X and x. What times itself is 36? 6 times 6. To make the middle term cancel, they have to be opposite signs. Done. That's it. It's nothing too crazy. Next one. Two sets. Again, they're perfect squares being subtracted. X times x is x squared. What times itself is 16? The square root of 16 is 4. We have a plus, we have a minus. And you could put the minus first, I just automatically always do plus first, but it's up to you. Getting a little harder. Change colors. Let's do green. Now, we know we have to have our x, but what times itself is 9? So 9x squared, we have our 3x times 3x is 9x squared. What times itself is 49? 7 times 7 is 49, plus, minus. Last one on this page. Pause it, try it on your own. I get so many kids that tell me the answer to this one is 50x and 50x. Remember, you are multiplying. You are multiplying. 50 times 50 is not 100. 10x times 10x is 100. 9 times 9 is 81. And for, just because, let's do the minus first. Minus plus. Again, order doesn't matter. Alright, I want you to pause the video and try these on your own. Alright, a little harder for this one. That's x to the 4th. So what do you think we're going to write? What times itself is x to the 4th? X squared. What times itself is 64? 8 and 8. Done. 13. Again, don't overthink it. I keep asking this same exact question over and over again. Don't overthink these. Just ask the question of yourself. What times itself is x squared? X times x. What times itself is y squared? Y times y. Plus, minus. Next one. Again, perfect squares everywhere, and I see a subtraction. What times itself is 4x squared? 2x and 2x. What times itself is 5y squared? 25y squared, I said the answer. 5y, 5y. Opposite signs. Now, order matters. A lot of students lose points on this because they will put the x first. X cannot be first, x is second. Subtraction is not, wow, my brain stopped working, commutative. You cannot, is it commutative? Oh my goodness. Yeah, commutative. You can, 7 minus 5 and 5 minus 7 are not the same thing. So order does matter. What times itself is 225, 15 and 15, x and x, plus and minus. That matters. The x has to come second in these. Alright, these are a little tricky, right? These are tricky. What times itself is x to the 4th? X squared and x squared. What times itself is 625? 25 and 25. Now, the reason this one's tricky is we actually can go do this again. Now, is this a dots? Is this a difference of two squares? No, because it's not a difference. It's a plus. So we're good here. X squared plus 25, you're done. But notice over here, x squared minus 25, that's perfect square subtracted again. So we're going to do this one more time. What times itself is x squared? X and x. What times itself is 25? 5 and 5. One's plus, one's minus. And we're done. How about 17? What times itself is 196 x cubed? A lot of students try to tell me it's 14 x squared and 14x. This doesn't work. If you try to double distribute, this, it will not work. You'll have craziness. So this one is actually prime. Alright, so you cannot actually factor that one. Last one. Oh, I thought I had a really hard one. I guess not. Alright, that's factoring using difference of two squares. Hope that helped. Have a great day.